Hello students, we were doing inverse trigonometric function. Today we are going to start next question, question number 18. Cos inverse, if cos inverse x upon a plus cos inverse y upon b is equals to alpha, prove that this. Now in left hand side, use the formula cos inverse x plus cos inverse y. Cos inverse x into y minus square root of 1 minus x square root of 1 minus y square. Now this cos inverse goes on the right hand side, so it becomes cos of alpha xy ab minus square root of 1 minus x square upon a square into square root of this. Now cos alpha on left hand side is equals to square root of 1 minus x square a square 1 minus y square and b square. Now squaring both sides, what we get? A minus b whole square, a square plus b square minus 2ab. When we squaring this side, square root will get cancelled. 1 minus y square b square. Now solve right hand side. 1 minus y square b square minus x square a square minus minus plus x square y square a square b square. This plus x square y square, this will get cancelled. Now we have left with cos square alpha minus 2xy ab cos alpha. Now we want these terms on left hand side. So when it goes on left hand side, sign will change. 1 minus cos square alpha. We know the identity sin square plus cos square x. Sin square x plus cos square x is equals to 1. So 1 minus cos square is equals to sin square. So this is what we want to prove. Plus y square b square is equals to sin square alpha. Note it down. Now second part. Second part is if cos inverse x plus cos inverse y plus cos inverse z is equals to pi, prove that x square plus y square plus z square plus 2xyz is equals to 1. Now we can write it as cos inverse x plus cos inverse y pi minus cos inverse z. Cos of minus theta when it is pi minus this. So instead of this, we can write it as cos inverse minus z. Now cos inverse x plus cos inverse y. Cos inverse xy minus square root of 1 minus x square root of 1 minus y square. Now both sides we have cos inverse, so it will get cancelled. Here we have left with minus z. Now we can write it as xy plus z is equals to square root of this. Now squaring both sides, what we get? A plus b whole square, a square plus b square plus 2ab. Here square root will get cancelled with square, so 1 minus x square 1 minus y square. So we get this x square y square will get cancelled. When these terms goes on left hand side, x square plus y square plus z square plus 2xyz is equal to 1. Clear? Note it down. Next is third part. If sine inverse x plus sine inverse y plus sine inverse z is equals to pi, prove that x power 4 y 4 z 4 plus 4 x square y square z square 2 into x square y square z square plus z square x square. Now we can write it as sine inverse x plus sine inverse y pi minus sine inverse z. Right? Now taking cos on both sides, cos of sine inverse x plus sine inverse y cos of pi minus sine inverse z. Now cos of pi minus sine inverse z. Pi minus sine inverse, that is equals to cos of pi minus is minus cos of theta. Here apply the formula cos of a plus b, that is equals to cos a cos b minus sin a sin b. Clear? Here we have applied the formula cos of a plus b, cos a cos b minus sin a sin b. Now cos of sine inverse x, that is equals to square root of 1 minus x square. How? If we put sine inverse x as theta, it means sine theta is x. Sine theta is x, base is 1 minus x square. Cos will get cancelled if we have the value of cos. Cos theta is base upon hypotenuse. Now we get theta as cos inverse 1 minus x square. So here we get cos of cos inverse 1 minus x square. Similarly, cos of cos inverse 1 minus y square. Sine and sine inverse will get cancelled, minus xy minus cos of sine inverse z. Minus cos of sine inverse z, similarly we get it as cos inverse 1 minus z square. Clear? Now square root of 1 minus x square, square root of 1 minus x square minus square root of 1 minus z square. Now squaring both sides, what we get? If we take this xy on right hand side, now squaring both sides, on squaring we get 1 minus x square, 1 minus y square, a square plus b square minus 2ab. 1 minus x square minus y square plus x square y square plus 1 minus z square minus 2xy square root of 1 minus z square. X square, y square and 1 will get cancelled. So we get z square minus x square minus y square minus 2xy. This. We get it as this. Now if we take negative common, so we get x square plus y square minus z square 2xy. This. Now we want the power 4 here and there is a square root, so squaring once again. Squaring both sides. What we get? A plus b plus c whole square. That is equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ca is equals to 4x square y square 1 minus z square. Note up to here. x4 plus y4 plus z4 plus 2x square y square minus 2y square z square minus 2z square x square is equals to 4 minus 4x square y square z square. So what we get? x4 plus y4 plus z4 plus 4x square y square z square 4x square y square minus 2. So we get 2x square y square, and this term will goes on right hand side. Sign will change, taking 2 common. X square y square plus y square z square plus z square x square. This is what we want to prove. Note it down. Now the next one. Now the next question is, evaluate tan of 2 tan inverse 1 by 5 minus pi by 4. Second part is tan of 1 by 2 cos inverse square root of 5 by 3. Now we know the formula for 2 tan inverse x, that is equals to tan inverse 2x upon 1 minus x square. So apply the formula here, tan inverse 2x 1 minus x square. Pi by 4 is the value of tan 1, so tan inverse 1. So tan of tan inverse 2 by 5, take the LCM 24 by 25 minus tan inverse 1. So we get 5 by 12. Tan of tan inverse 5 by 12 minus tan inverse 1. Now apply the formula tan inverse x minus tan inverse y, that is equals to tan inverse x minus y upon 1 plus xy. Use the formula here, tan inverse x minus y 1 plus x into y. ये आया हमारे पास. So what we get? Tan of tan inverse, take the LCM 12 minus 5 minus 7 by 12. LCM 12 plus 15 is 17. So we get tan of tan inverse minus 7 upon 17. Tan and tan inverse will get cancelled. So the answer is minus 7 upon 17. Clear? Now, in second part, put this value cos inverse root 5 by 3 as theta. So we get cos theta as root 5 by 3 base upon hypotenuse. Hypotenuse square minus base square, so this is 2. Now tan theta by 2. We can write tan as sine upon cos. We can write tan as sine upon cos. Now we have formula for cos 2 theta, that is equals to 1 minus 2 sine square theta or 2 cos square theta minus 1. If angle is half, then we get 1 minus cos theta upon 1 plus cos theta. We have the value of cos theta root 5 by 3, 1 plus root 5 by 3. Take the LCM 3 minus root 5 upon 3 plus root 5. If we rationalize it, 3 minus root 5, 3 minus root 5. So 3 minus root 5 square, a plus b, a minus b, a square minus b square. Now the next one. Write down the statement. If tan inverse square root of 1 plus x square minus square root of 1 minus x square upon this is equals to alpha, then prove that x square is equals to sine 2 alpha. We have to prove x square is equals to sine 2 alpha. We can write this as 1 plus x square plus 1 minus x square is equals to tan alpha upon 1. So apply componendo and dividendo here. So the term which is in denominator, we have to add this term in the numerator and subtract this term from the denominator. So we can write here 1 plus x square. जो टर्म डिनोमिनेटर में है उससे ऊपर हमने क्या करना है प्लस, और उसी टर्म को हमने नीचे क्या करना है सब्ट्रैक्ट, and the term which is in numerator we will write it as it is. Now what we get, 2 times square root of 1 plus x square. Here 1 plus x square will get cancelled, minus 2 square root of 1 minus x square. If we take negative common from here, negative will get cancelled. So square root of 1 plus x square upon 1 minus x square, 1 plus tan alpha, 1 minus tan alpha. Now reciprocal, we can write it as this. Instead of tan, we can write sine upon cos, 1 plus sine upon cos. After taking the LCM, cos alpha minus sine alpha upon cos alpha plus sine alpha, square root of 1 minus x square, 1 plus x square. Now to remove the square root, squaring both sides, 1 minus x square, 1 plus x square, a minus b whole square, a square plus b square minus 2ab upon a square plus b square plus 2ab. Clear? Now in the next step, 1 minus x square upon 1 plus x square. Cos square plus sine square is equals to 1. 2 sin x cos x is equals to sine 2x. So sine 2 alpha here. 1 plus sine 2 alpha. Now cross multiply 1 into sine 2 alpha minus x square sine 2 alpha. 1 into sine 2 alpha plus x square minus x square sine 2 alpha. Minus x square sine 2 alpha, 1 will get cancelled, minus x square and plus x square. When this x square goes on left hand side, here we have minus sine 2 alpha and this is minus sine 2 alpha. So minus 2x square minus 2 sine 2 alpha. Minus 2 will get cancelled from both sides. So we get x square is equals to sine 2 alpha. Note it down. Now the next one, by 2 tan beta by 2. We know that 2 tan inverse x is equals to 1 minus cos square upon 1